All right, we are back, and I'm going to keep erasing. I'm going to go through for A and B as quick as I can. And yeah, and then we're going to keep moving on to other questions. Hopefully we have a good understanding. So when I look at a problem like this now, question 4 A and B, they're very similar to what we just saw with question 3. So it's just saying, hey, are the points on the parabola? Right, so I'm going to plot -3, 3. Okay, well, it's right here, generally speaking. Again, how do I test it? I test the distance down to the directrix, so that's 1, 2 units. So there, 2 units. Now I try to find the distance from my point to the focus. So that's right across there. That is from -3 to -1. That's also 2, so yes. Please show a lot more work than that, but again, through my video, I'm trying to get a little quicker through these. So, but just show, distance to directrix equals, and then show somehow how did you figure that out? Just me drawing on the graph is good enough work, honestly, sometimes. And the distance to the focus. For part B, -4, 4.5. Let me erase some of this work here. -4, 4.5, that's actually like up here. Doesn't quite look like it's on there, so we'll check that. The distance to the directrix. Here's my directrix. I'm going to go up 1, 2, 3.5, because that's up 4.5 total. So my question is 4.5 equal to the other one? Well, I don't know. I'm going to draw a line straight over to that. So I'm going to draw point 1 as the coordinate. The other one is my focus. And again, I want to know that straight line distance. Okay, so what I can do is in the x direction, I was -1, -2, -3, -4. So I have 3 units in the x direction. I was up 3. Now I'm up 4.5. So that's 1.5. So Pythagorean's theorem says if I take the square root of 3 squared plus 1.5 squared, I will get the distance to the focus. And if I run that in my calculator, it's like 3.38 something, I think. The point is, it's not exactly 3.5. I'm sorry, I just caught this horribly gross error. My distance to the directrix, sorry about that, is 3.5. So from 1, 2, 3, 4. Okay, so my distance is 3.5. No matter what, the distance to the focus, I just used Pythagorean's theorem, and I realized it's not exactly 3.5, so it is not, even if I round it to 3.4. Please, I've had several students asking, let's say that was 3.48, okay, 3.48 something or other, and I said, well, that rounds up to 3.5, so doesn't that mean that this works? The answer is no, absolutely not. If that is not exactly the same value all the way carried out, it is not going to be on the parabola. So this one was 3.38, so no, it is not on the parabola. Hopefully that made sense. I'm going to move on. Question 5. Okay, kind of still on parabolas, but we're working more on, I just said more on. We're going to work more through questions that find the zeros. So when a graph is given and it says select the equation that could be the function, well, what they're really saying is when I graph these parentheses, x minus 1, x plus 3, I know that if I can set this parenthesis to be 0, what that means is, so for example, if I plugged in x equals 1 into this equation, I would get 1 minus 1 and 1 plus 3. The point is, this first parenthesis becomes 0. Sure, this becomes 4, but it doesn't matter because 0 times anything is 0. So if I plugged in 1 as my x value, I come over here, my y value for the graph would be 0, right? Because I plugged it in, x is 1, I got y was 0. So this tells me that my graph would do something like that. It would have to strike through the x-axis at 1, and obviously from the graph given in blue, it is not. So what we're trying to do is say, hey, why is this not working? There we go. What two equation parentheses are such that when I plug in the values, I get 0. So at -1, how do I get 0? Well, if I plug in -1, I get 0. Or rather, I'm looking for a set of parentheses that if I put in -1, I get 0. So if I put in -1 minus 1, I don't get 0, I don't get 0, so this equation will not work. Same thing here, x minus 1. If I plug in -1, I get -2 and -4. I'm not getting y equals 0. Here I do. I get x plus 1. So -1 plus 1 is 0. So my whole equation would be 0, meaning that if I plug in -1 in the x-axis, I go up 0. So that one right there works. Let's also check x minus 3. Well, this one here crosses at 3, so we have to plug in 3 for x, and we would expect a 0 out in the y. 3 minus 3 is 0. 0 times 4. Check box. All right. The answer is C. It's not D, because even though x plus 1 gets me 0, if I plug in 3 plus 3, I get 6, and that doesn't work. So hopefully that helped kind of generalize that, right? If I have a function and I'm looking for the zeros, or if I'm given the graph and find the equation, the correlation is that inside the parentheses, if I can set the parenthesis to 0, so like 1, if x is 1, I get 0, then 1 in the x-axis would be one of the parts where the graph crosses the x-axis. Question 6. Here's the graph, write an equation. Okay, so back to, we're kind of working backwards here, right? So I have 2 points where the graph crosses the x-axis. So I know that if I said x minus 2 times anything, when I plug in 2, I would get 2 minus 2 is 0. That satisfies this point, because everything else, it doesn't matter. 0 times anything is 0. So the other thing I have is I know another point in the graph crosses at 6. So I need to get this to a point where the graph crosses the x-axis, y equals 0 when x is 6. So x minus 6 satisfies that. So x minus 2 times x minus 6, I would eventually get my curve. I have my zeros at 2 and 6. And I should probably like throw in the y equals there. But that's it. That's as simple as that is. You just look at how to get my graph set to 0 at the given points where it intersects. If this were to have crossed in the negative, I would say like if that crossed at -1, I would say x plus 1 and then x wherever the other point crossed. So just keep that in mind, that the signs can change. It's just a matter of getting the parentheses set to 0 based on where the line crosses the x-axis. Okay, that's enough for this video, because 7, woo, boy howdy. 7A is easy. It's B and C where we have to complete the square. So I'm going to go ahead and pause there, start a new video for 7, and we will start completing the square.